this question: all nodes distance k in a binary tree. This question we're given the root and the value of a target and an integer k. And to return an array of values of all the nodes that have a distance k from the target node. Remember, we have to return array of values of all the nodes. So let's say we have this example. This is my root, this is my target, and the value of k is given as 2. So if I check, I find out that 7, 4 and 1, these are the 3 nodes which are at distance 2, that is k, from the target node. So since we are given a binary tree, and in binary tree we can only traverse from a current node down to its children. We don't have any parameter using which we can traverse from any node to its parent. If in any case we want to travel from a current node to its parent node, we would either have to make a custom array or some other data structure to store the value so that we can traverse. So an efficient way of solving this question would be using graph. So what we can do here is, given a tree, let's make a tree. Let's say this is my tree. Okay. So let's say this is my tree. So now how I will convert it into a graph? When you want to create a graph, we have two options. Either we can create it using adjacency matrix or using adjacency list. If we use adjacency matrix, it takes up more space as compared to the adjacency list, because we know that each node might not have n number of neighbors, so we just use extra space to allocate space if there exists a neighbor. So I prefer using adjacency list. You can choose either of those. So if we convert it into an adjacency matrix or graph, how it will turn out. For 1, let me just mark out 2. Okay, so for 1 I can see that 2 and 3 are its neighbor, so I will add 2 and 3 for it. For 2, this 1 is also a neighbor, so I will add 1 here also. For 2 I can see that 1, 4 and 5, so I will add 1 is already there, I will add 4 and I will add 5. In 4 also I will add 2, and in 3 I have 1, 6 and 7. So 1, 6 and 7, and in 6 also I will add 3, 7 also I add 3. For 4 there is only one neighbor, that is 2. Similarly for 5 only one neighbor, that is 2. And same way for 6 and 7, only 3 is the neighbor. So this is how we can convert it into an adjacency matrix, and the efficiency or the better advancement we get on converting a tree to graph is that we can traverse in any direction we know using DFS or BFS, whichever you guys are comfortable with. So how we'll approach this question? We will simply, let's say we're given, I have already written the code. Let's say we're given this question or this function to do. We have a root, we have a target, and we have a key, and we have to return an array, vector int of the values of all the nodes that are at distance k from the target node. So first of all, what I'll do is I'll create graph. Let me just walk you through the create graph function. I've created a map for storing adjacency list. I declared it globally, and also a visited array and an answer array to store the answer. I've created them globally so that I don't need to pass them in every function. You can make it locally and pass them to another function as it fits you guys. You can do it either way. So this is the create graph function. In this, if the root is null, I'll just simply return. Otherwise, what I will do is I will check if the left exists or not. If left is not null, I will add left to the neighbor of the root and in the neighbor of left I will add root. Similarly, I will check if the right exists or not, and if right exists I will push it to the neighbors of the root, and similarly I will to the right I will add root as its neighbor, and then I will call create graph on the left and create graph on the right. So this is how we'll create an adjacency list for a given graph, and then we can do a further calculations. After creating a graph, what we'll do is we will, since the number of nodes which we can have maximum is 500, so I'll make the visited array of max size 500. You can either count the number of nodes, use the max size as it suits you guys. I've taken it as max size. Then what we'll do is we'll call DFS. You can also use BFS if you are more comfortable with BFS. In BFS or DFS, what we'll simply do is, since I'm doing DFS here, so I'll explain using DFS. In DFS, what we will do is we will simply pass two parameters, that one will be the node and the other one will be the value of k. So like we will check if the value of k becomes 0 at any point, that means this node is at a distance of k and I need to push it to my answer, and simply return, because after that k value will only decrement, and the set property that the node has a distance k will not be satisfied, so I will simply return. If this is not the case, I'll mark the current node as visited, and I will traverse on all its neighbors. If they are not visited, then I will call DFS on them, like using X as a node, and I'll decrement K. I'll decrement K because let's say I have a tree. I'll make it in a form of graph only. 2, 3, 4, 5. Let's say this is my tree and this is my target node, and K is given as 2. So the only node will be 2. I'll commit 3. I pass it at 3, and I will check. Like we can see in DFS, I passed the function call on target node, and initially at the target node, and I will check if k value is 0. Since k is not 0, so I will call on its neighbor. One is 5 and one is 2. Here the k value which will be passed will be 1. K value is not 0 over here, so we'll check for all of neighbor. 3 was already visited, so we have no other neighbor, so we'll discard this call and we'll return back. Then when we come to 1, k value is 1. K value is not equal to 0, so our base condition is not satisfied. I will mark it as visited and pass on its neighbor. Since we can see that 3 is already visited, so we'll not go back to 3, we'll go to 2. And then here the value of k which will be passed is 0. I know that this is my base case. If k value becomes 0, then I have to add this particular value to my answer. Let's say this is my answer vector, so I will add 2 in here. So 2 will be added, and since k became 0, I'll just simply return back. I see that there is no other node which are at distance of k from the target node, so I simply return. So this is how we do this question. You can do it using tree also, but I find it more easy. While if we do it using graph, you can do it either way, but here is a code. If you want to do it using a graph, simply just create graph, make a visited array, and call DFS on target node. In graph, we use adjacency list to add the neighbors, and then in the DFS function, if we reach the base case, that is k is equal to 0, that means current node should be an answer. We add it to answer and return, otherwise we mark it as visited and call on its neighbor, decremented the value of k by 1 each time, so that I can keep track of how much distance I have calculated or how much distance I have moved until now. Let me know if you guys have any doubt or any confusion.